So who can give me an example of a liquid? What are some things that you might have in your house or have seen outside or in the supermarket or at school that are liquids, that are items that can be poured? These items are usually wet and they are usually things that we drink or we swim in. Things might be water, orange juice, apple juice, any kind of juice. When we go to the beach, we swim in the ocean. That's a liquid. We swim in pools, and pools are filled with water. We drink milk. All kinds of things like those are considered liquid. And I bet you could come up with so many more if you walk around your house and you really look and see what kind of liquids do I have in my house. So I want you guys to do that. But an experiment that we are going to do today is we're going to show how the particles inside liquid, remember those are all those little things that are moving around inside of a liquid, in all of the inside of the matter. Those particles are loose. They're not really far apart, but they do have, remember, they have elbow room, which means that it can take the shape of whatever container the liquid is poured into. For example, what our experiment is going to show is I have 3 measuring cups over here. Each measuring cup has 1 cup of water. And I'm going to show you guys the measuring cup before I pour it so that I can show you that each measuring cup has the same amount of water. Now, I walked around my house and I found 3 different containers. I found a bowl, I found a cup, and I found a water bottle. So I am going to pour each one of these measuring cups into one of my containers. And remember, it's the same amount of water. But what we're going to see is, does the liquid look the same in each container? Does it look like it takes up the same amount of space? Does it take up more space? Does it take up less space? Does it take up the same space? We're going to see, because this is going to show us how water moves around more freely than maybe if it was a solid. Like if we froze the water and it was an ice cube, it wouldn't be able to move around because it would be an ice cube. We would have to wait for it to melt for the liquid to start to move. So this experiment, like I said, is going to show us how water moves around a little more freely and will take the shape of whatever container it's poured in. So let's start with the first measuring cup, and I'm going to bring it up close so you guys can see it is 1 cup of water. And what I'm going to do is I'm going to pour it into my container right here, and it's a bowl, and it's actually a Pyrex bowl. It's empty. And I'm going to pour it in nice and slow. And that's it. So look at that. It's filled. It didn't take the whole container. It's nice and spread out because my container is wide and it's deep. So it only took up to about there. Now I'm going to take another measuring cup, and again, so you can see 1 cup of water again, and I'm going to pour it into my cup. And I picked a short cup, and let's see how much space it takes up here. Ooh, look at that. It almost filled up the entire cup. Just have a little bit more space left. So look at that. Did it fill this container? No. Why? This container is much bigger. It's much deeper. Did it fill this container? Almost. Why? Because it's smaller. So it has less room for it to spread out. So now I'm going to use my water bottle. And again, I'm going to bring it up nice and close so you guys can see. 1 cup. And I'm going to pour it into my water bottle. Nice and slow. We don't want to have any spills. All right. And when we are done, we'll take a look. And look at that. Did it fill the whole water bottle? No. Even though it's a small space, the water bottle is very tall, so it won't fill it up like this did because it's short. So look at that. The same amount of water in 3 different containers. And does it look the same? No way. This one is very, it looks like it didn't even fill half of it. It's very wide, it's very flat, it's very deep. So the water did not take up a lot of the height, but it did take up the whole bottom. This one, because the glass is smaller, it took up more space. It was able to take up more of the glass. And this one, it didn't fill up much at all, but it's because it's a very, very tall bottle. So I want you guys to do this at home. Walk around your house, in your kitchen, anywhere, and find at least 3 different containers. If you find more, that's great. You can do this with as many containers as you want, really. Really big containers, really small ones. If you have like any glass vases that are kind of a different shape, if you have really small glasses or really tall glasses, because if you use really small ones, there's a chance that it won't even hold the liquid and it'll actually overflow. So you'll get to see it pour out. But find a couple of containers, take a measuring cup or a couple measuring cups, and put the same amount of water in each container. Now, I chose to do a cup of water. You can do more, you can do less, you can do really whatever you're comfortable with. But like I said, I want you to see how water takes up different space in each container. It's the same amount of water, but it looks different, because those particles are able to spread out a little bit more. It's not like as if it was a solid. Solids are so tight, it has nowhere to go, so it has to stay together. This liquid was able to spread out and cover the container. So definitely walk around, see what you guys can find, and let me know. And I look forward to seeing your observations and what you guys figure out. And we'll be back in a little bit for another activity. We're going to do a liquid race, and I hope you're ready. All right, see you later. Bye.